The next generation of long-range aircraft are currently in development. To power them, GE is creating the most advanced commercial turbofan in our history, the GE NX. This engine will offer amazing advantages, but because these advantages are the result of proven technologies, it will offer all of the reliability you expect from GE. Let's take a quick look at some of this engine's most striking innovations. One unique feature that sets the GE NX apart is its use of composites in the fan. These materials are light, durable, and incredibly strong, and have been proven in service on GE90 fan blades. We will now extend our success with these materials to the fan case, making it lighter and more durable. Aft of the fan is the low-pressure compressor. As with many components in the GE NX, it incorporates the latest 3D aerodynamic improvements, as well as a debris-rejecting system to keep foreign material from entering the compressor. The heart of every turbofan is its core, and at the heart of the GE NX is the most efficient, compact core we've ever produced. It features a 10-stage high-pressure compressor that uses 4 fewer than the engine it will replace. Fewer stages mean fewer parts and less cost. This efficient compressor will deliver an astounding 23-to-1 pressure ratio while providing the same stall-free operation GE is known for. If most combustors operated at the record pressures inside the GE NX, the flame temperatures would be unacceptably high and wouldn't keep NOx production in check. Not so with the GE NX, where we will feature an advanced TAPS combustor in development since the year 2000. This combustor keeps temperatures low by utilizing lean burn combustion and a more uniform gas stream temperature profile, reducing the severity impact downstream. Turbines extract energy from the core flow. Here, by utilizing our advanced design codes, fewer blades can now do more work. In addition, a counter-rotating architecture enables an even more efficient extraction, allowing for a 10% part reduction in select stages. All of these technologies have come together in one engine, providing maximum value and operating efficiencies previously unheard of. Even when it's in the air, the GE NX is under the microscope. By using integrated diagnostic technology, the engine can monitor its own condition, diagnose faults, track performance history, and even monitor part life limits. When this engine has to come off wing, it employs an innovative modular maintenance concept designed to deliver significant savings in time and cost. The engine easily splits into 2 modules, the fan and the propulsor. When the time comes for maintenance, the propulsor can simply be removed and replaced with a spare one. The GE NX is a giant leap forward. It takes advanced, proven technologies and combines all of them into one efficient, reliable turbofan. It is the first great engine of the 21st century. It is imagination at work. Rising energy costs in a world of ever-changing regulations are putting our customers under enormous pressure. To help, we put the GE NX under a lot of pressure too. Its compressor provides the highest compression ratio in aviation, helping make the GE NX burn lean and clean. GE has long set the standard for reliable, stall-free compressor operation. The GE NX extends on that legacy with a tremendously efficient compressor. With only 10 stages, it will achieve the highest pressure ratio ever. One of the ways we achieve such remarkable efficiency is through the use of advanced 3D aero technology in the design of the blades and vanes, maximizing airflow through the core and optimizing tip clearances. 3D aero technology is also applied to the bladed discs, or blisks, that comprise 3 of 10 stages in the compressor. As a single component, a blisk has far fewer parts and weighs less than a conventional assembly. There's no dovetail wear to worry about, and blisks are highly damage resistant. In the aft stages are unique powdered metal discs that are specially designed for a high temperature environment. These discs and new ceramic bushings will help reduce part wear and extend hardware life, giving GE NX customers an unprecedented level of reliability. Improved materials and design will help create the latest in a long line of outstanding GE compressors. Just imagine how we've improved the other parts of the GE NX engine. Our customers asked us to help them lead the charge toward a cleaner, greener future. To meet that goal, we did a complete engine overhaul and created the most advanced combustor in the industry. With our innovative single-annular TAPS combustor, the GE NX is designed to be the cleanest burning engine in its class. This combustor will far and away comply with all existing and expected regulations for NOx emissions, positioning GE/NX operators for clean compliance for many years to come. Cleaner combustion requires technology that delivers high efficiency and lower, more uniform flame temperatures. This is achieved with our innovative pre-mixing concept. By directing nearly all of the airflow through unique swirlers and around nested fuel nozzles, we create the ideal pre-mixed fuel-air environment. And because NOx production is strongly driven by combustion temperature, these emissions will be drastically reduced. Additionally, because all of the combustion air enters through the dome and mixers, no dilution holes are required on the new liner. This in turn reduces distress, leading to longer liner life and reduced maintenance costs. The lower and more uniform temperatures produced by this combustor have another benefit as well. They significantly improve the lives of all downstream components. This clean, easy-to-maintain combustor is one of the many innovations that will give GE/NX customers advantages unavailable to anyone else. Just imagine how we've improved the other parts of this amazing new engine. The turbines are the most aft components of the GE/NX, but they are hardly an afterthought as they use materials, coatings, and architectures that are truly revolutionary. The job of the high and low pressure turbines is to extract work from core flow. This efficiency has never been better, thanks to recent improvements in design codes and turbine blade architecture. Fewer blades can now do the job more efficiently, while simultaneously reducing cost and weight. The bulk of engine maintenance costs are driven by the life of the turbine components. By including the use of new, more temperature-capable materials and reducing the severity of the operating environment, we've limited the maximum temperatures these components will experience. The design will feature unique powdered metal rotors, specialized coatings, enhanced cooling techniques, and new blade materials, delivering a turbine with the right balance of performance and extended life. When it comes to the low-pressure turbine, we decided to put a new twist on things by incorporating a counter-rotating design. This technique, rigorously tested in other engine programs, provides numerous benefits, including fewer parts, less weight, and improved efficiency, with no additional architectural complexity. Also, this turbine is specifically designed and shaped for maximum performance, and in addition, achieves great performance retention. The turbines in the back of the GE/NX use an impressive variety of innovations to lower life cycle costs. Just imagine how we've improved the other parts of this amazing new engine. Many of the innovations on the GE/NX are hidden deep inside. Not so with the fan assembly. Here you can see two of the engine's most important and most distinctive features: its composite fan blades and case. The blades are the third generation to be made of carbon fiber composite material combined with a titanium edge. They are so durable that only 3 have been removed from service in the first 6 million flight hours. In addition, they are very light in weight and are more fatigue resistant than titanium at less than half the density. Because these composites are extremely strong and can be intricately formed, each blade can be made larger and more aerodynamic. And since they move more air, only half the blades are needed. Additional weight savings and strength are found in the fan case, which is made with a braided carbon fiber material. This composite provides 30% better containment characteristics and eliminates corrosion concerns inherent in metal designs. It also provides better clearance matching thanks to the better thermal stability of composites. Composites enable a larger fan. A larger fan is necessary for a high bypass ratio, which is a key component to reduce the engine's fuel consumption. The high bypass ratio also reduces noise. The GE/NX will be 13 decibels quieter than its predecessor, a significant amount that will enhance the cabin environment and reduce noise around airports. Designed to be the quietest commercial engine we've ever produced, it will be well within global regulatory requirements far into the future. Air isn't the only thing that can enter the fan. Foreign objects can too. That's why the GE/NX engine's spinner, wide chord blades, and LP compressor are designed to centrifuge debris away from the core. In addition, bleed doors act as scoops to direct any remaining debris out. As a result, the core gets a clean, uninterrupted flow of air. Finally, the outlet guide vanes bring a lightweight honeycomb-filled structure that is so strong, the total number is 40% fewer than the engine it replaces. While they may not move, they are nonetheless revolutionary. Any new engine is going to require thought up front, and that's precisely where we directed a lot of attention up front at the fan module. As a result, we found ways to improve efficiency, performance, and cost using a variety of proven advanced technologies. Imagine what we were able to do with other parts of this amazing new engine. The GE NX engine is designed from front to back to improve airline efficiency. That's why its front and back are modular units that can be separated when the time comes for maintenance. The fan module is built with durable composites to make it virtually maintenance-free. So when the propulsor module of the GE NX needs maintenance, simply remove it and leave the fan unit with the airframe. Attach a spare propulsor to it and you're ready to fly. This innovative solution can reduce your spare engine acquisition cost by 10%, giving you the flexibility to buy propulsors instead of complete engines. Smaller and much lighter, propulsors give you greater flexibility when storing, handling, and shipping them. Your transportation costs will be much lower, and your logistics will be greatly simplified. The unit is compact and light enough to be shipped by most conventional means of air and ground transport. Unique to GE, the propulsor concept was first proven with the GE90 and is now available with the GE NX. It's an example of how we're willing to think outside the box to help customers succeed, or even outside the fan. Just imagine what we're able to do with other parts of this amazing new engine. The GE NX is not just a piece of hardware. It is truly an intelligent engine that is capable of monitoring its own condition, analyzing potential faults, tracking performance history, and even monitoring part life limits. It is able to do all of this thanks to GE's combination of intelligent technology and years of diagnostic experience. Sensors are located on subsystems throughout the engine. These sensors feed data into a diagnostic computer that contains a database of operational history, as well as a model of optimal engine performance. This GE database was generated using thousands of engines over decades of flight. During operation, the sensors send data, which is compared in real time to historical performance, as well as to the model. It automatically looks for variations in operating parameters, tracks engine performance, and helps troubleshoot faults that occur. Thanks to this automated process, the GE NX engine improves fault isolation up to 75% over its predecessor. This can mean big savings in maintenance costs. But more than just tracking performance, the GE NX will provide an automated and engine-specific maintenance history. Tracked by serial number, your engines will know what's been done to them and what needs to be done to them. Now, maintenance will know the complete engine history, what is needed for a particular job, and when that job needs to be done. In addition to overall operational history, the GE NX can track the history of individual parts by serial number. Life-limited parts, in particular, can be tracked by the actual severity of their use. The system tells you when to replace them. With this technology, your maintenance staff will be synchronized with every GE NX engine in your fleet. Flight crews will know in advance when they have a developing situation, and you'll know that the cost savings and operational efficiencies make the intelligent engine a very smart choice indeed.